All right. I think we've got given everybody enough time to get on. So I think you all can see me, but you can certainly see the slides. My name is Blake Murphy. I'm the president of American Pipeline Solutions, and today we're going to be doing a webinar on foam pigging, ice pigging, as well as a little bit of condition assessment and even something called water blasting. My intent is to keep this at about 45 minutes. It's also to keep this as much of a discussion as possible. So please, if you have a question, either drop it in the chat or raise the little hand emoji, and we will answer the question. And feel free to make this as much, again, of a dialogue as possible. My goal is for everyone to walk away with a good understanding of foam pigging, ice pigging at a 30,000-foot view. And then when you look at your pipelines, at least have an understanding of which option would be the best, and then at least where to start. So the first thing I like to do when describing or explaining pigging, foam pigging, is to have everybody imagine the foam on their couch cushions. So it's very compressible, it's malleable, and it's soft, and it's a low density foam, and so that you take that and you carve it into what resembles a bullet, and that is a pig. We will take these pigs and we will put them in one end of the pipe. We'll push them through, and as they go through, they will remove all the dirt and debris that's built up over time in those pipelines. We will use either whatever is already in the pipe that's flowing through the pipe. So think about force mains. We're going to use the water coming out of the lift station, or for potable water systems, we're going to use the flow that's already in the pipe. And I will talk a little bit more about the setup and how we will launch that pig into the pipe. I'm going to try to show you guys a video at the end. There's a couple of videos I'm going to show. Instead of going back and forth, I'll wait until the end to show all the videos. But I'm going to show you exactly just how soft these different pigs are. And then you can actually wrap these pigs in a different material, which based on what you're trying to remove from the pipeline, the pig can be either a higher density, so it's going to be a little bit harder and provide a little bit more of an abrasive scouring on your pipe. And it all comes down to basically something that we call, or a method that is used for pigging, which is the progressive pigging method. And so what we do is we start with that light density foam pig that I was talking about. And you will run that through the pipe first, and then you will start to slowly build up the density level of the pig that you're going to use, both density as well as the type of material, the exterior that the pig is covered in. So for those of you, for instance, that might have a cast iron pipeline from, say, the early 1900s, it's going to be heavily tuberculated. What you would likely do is you would run the swab, that light density foam pig, through the line initially, and then you're going to start building up to higher density foam pigs, and then eventually you're going to end up with a pig that's likely going to be wrapped in wire, and I'll show you a video of what that looks like towards the end. And so that wire brush is going to be providing the most scour for that pipe as it removes, or as it flows and moves through the pipe. It's going to remove that tuberculation. So basically, there's different pigs for different jobs, and the job and the pig is all dependent on what you have in your system. Some other things about pipeline or foam pigging that are kind of key takeaways for everyone on this webinar. First is that the pig can travel miles and miles of pipe. So for instance, we have done jobs where a pipe was 50 miles and we used one pig to clean the entire run of the pipeline. And so really there's no limitation for how long you can run these, and you can do them all all in one go. The other great thing is that these pigs will compress to about 50%, or at least the lighter density ones will. So that means that if you have some sort of obstruction or there's debris that's very, very hard that's built up in your pipeline, those soft foam swabs that we start off with will actually compress and go around. And I'll show you a picture on the next slide of what that looks like. But the pig will also break up if it is not able to move around whatever object or debris is in the pipe. A good example of that is actually 2 weeks ago, we were on a job and we were cleaning a water system. And I think it was a larger diameter, maybe 20 inches or so. And we were cleaning and they had some butterfly valves in their system that they did not know were there. And so because we started with that light density foam swab, the pig actually came apart in the pipe. And so when we received it on the other end, we knew that there was two things. Either there was a lot of debris built up in that pipe, which we didn't believe to be the case, or they might have a butterfly valve in there that they weren't aware of. And sure enough, they went back and actually were able to identify multiple butterfly valves that were in that line. So that's always why we start with those light density foam swabs, and also why we use something called the progressive pigging method. Are there any questions before I move to the next slide? Okay. So I always try to, when doing these types of webinars or presentations, is showing why pig. I can sit here and talk to you till I'm blue in the face and tell you how great it is. But this was the results of a force main pigging job that we did about a year and a half ago in Naperville, Illinois. And so the bottom line and key takeaway from this is that they were able to basically increase their gallons per minute by almost 800, and they were able to decrease their pump run times by almost 2 hours per day. And so the key takeaway from all of that was that when the client actually went and ran the math on how much cost savings they had from those extended pump run times, they actually were able to pay for, or pigging paid for itself within 9 months. And so that's a real big statistic that we always like to showcase and advertise to people who are interested in pigging, is that it benefits and behooves you in a lot of ways. And I'll show you some results in pig or pipelines that were not pigged. But it behooves you to clean your lines, and also eventually the service will pay for itself just on the cost savings from an energy perspective. All right, so as I said before, the foam swab, the one that we start off with in the progressive pigging method, that is a good picture of a foam swab. This job was one that we did in Central Virginia last year. We were brought in to de-water a pipeline in preparation for some mapping to be done, some XYZ mapping. And so we came in to clean the pipe and also de-water it. And sure enough, when we ran our first swab through, it came out and it pushed, as you can see, a sizable rock. And so it could have broken up. And I think you can see in that picture how it's starting to kind of come apart. But it was able to successfully push that rock out of the line and remove it. And you can see that that rock, compared to the diameter, is almost 50% of the size of the diameter, maybe a little bit less. And so I think, this picture is obviously worth 1,000 words, but it also shows you that even on lines that you might have that are in place right now, pigging them just to ensure that they are clear of any debris is also essential. Another kind of quick story is that we were brought in on another force main in Northern Virginia on it was a 3-year-old force main that was not, it was about 8 inches and it was not performing to spec. And so it was a directional drill, HDPE, and they just couldn't figure out why it wasn't flowing the way it was supposed to. And so they brought us in to pig the line, and based on what gallons per minute they were actually able to get, we had a hunch that the contractor who had done the work had likely left some sort of rock in the pipe, and it does happen. And sure enough, we pigged the line and the pig, and we were able to track it, which is one thing I forgot to mention, is that these pigs have the ability to be tracked. And so inside of them, and I'll show you in one of the videos, there is a cavity where you can put a transmitter and track exactly where that pig is. And so we sent that trackable pig into the pipe, and it got hung up in the middle of a field. And we were able to, with the contractor, immediately locate that pig, dig down, and pull out the pig as well as the rock that was pretty much similar in size as to this one. It's about 50% of the diameter of that line. And then they were able to restore their flows, and they started getting the flows that they were supposed to get based on the spec. So in addition to obviously what I said, which is removing that debris, benefits of pigging. So one of the great things is that you can pig a line and you don't have to take it out of service. So for force mains and for water mains or whatever pipeline that you're looking at, the pipe we're going to launch the pig, and I'll show you this on subsequent slides. We're going to launch the pig with an external pump into the line, but then it's going to be the natural flow of whatever is in that pipe that's going to move that pig. So think about not having to de-water your pipeline in order to be able to clean it or even to inspect it. Naturally, when you remove debris from a pipeline, you're going to remove that corrosive material that is essentially eroding your pipe. And so that's naturally going to also mean that you're going to get improved efficiency, but you're also going to increase the life span of your pipeline. So if you don't have that, that H2S or whatever the debris is that's really sucking out everything from the pipe, then you're going to get a lot of life left with that pipe. Okay, so this is a pig launcher on the right-hand side. On the left-hand side are the different options for hooking up a pig launcher. As I said before, there's different types of pigs for different jobs. And so for most jobs, we always prefer a Y on the bottom, as you can see, a Y entry point, because that allows us to use the widest variety of pigs. So for that wire brush pig that I was talking to earlier, that wire brush pig is not going to be able to compress the same way as that soft foam swab will, or even a medium density pig would be able to do. That wire brush can still navigate 90-degree bends, but it usually needs more speed in order to do that. And so it's harder to launch those types of pigs in, say, a T. And so that's why we always recommend hooking up a Y if possible, or setting up your pipeline for pigging. If you're thinking about down the road and you want to build a pigging station, make sure that it's going to be a Y entry point and not, say, a hard 90. Also, when we come to do pigging, we need an entry point, which you can see on the left-hand side. We're also going to need a water source. And so for potable water systems, usually we can just pull right off of a hydrant, and we'll put that water into our lagoon. And then we're going to bring an external pump. Now we use that external pump to launch the pig into the system, either for potable systems, we can launch a pig through a fire hydrant, or we just need any sort of entry point. Sometimes it's going to have to be a contractor coming to dig into the pipe and drop the proper Y piece and a valve for us to then get access to. But you can foam pig through hydrants, which is something that a lot of people don't know. and you can also retrieve foam pigs through hydrants. And so there are a lot of options for launching and retrieving of pigs. Going into pressure pipe, specifically force mains, we'll typically hook up to a blind flange, or we can at the lift station, or we can go through the bypass line, assuming that the bypass line is similar or closer to the nominal diameter. Again, because the pigs can compress to about 50%, we can still launch pigs that are bigger that will go into the pipe. But again, you're going to restrict the types of pigs that you can use, just because the compressibility of some of those more dense pigs, or pigs that can scour, you won't be able to launch those into a bypass line that is not going to be similar to the nominal diameter. I'm just going to scan over here and see if I have any questions I need to answer. All right. Nico Hendricks, have you heard of the opportunity to insert the pig into your force main from street level without a manhole? So yes, so you can do hopefully I understand, Nico, and I will see if I can find you, but if you can just enter into the chat if I'm on the money or not. But you're trying to not insert the pig at the force main or at the lift station. If that's correct, then yes, you can tap into the force main. You just need to work with a contractor, if you're not going to do the work, and install ideally a Y and a valve to be able to isolate that line. Hopefully that answers your question. If not, feel free to drop another one in there. But the great thing, again, is that you don't have to take your force main offline. You just need to make sure that your wet well is not going to overrun, which you can either do by pumping your wet well down or bringing a vac truck on station. And for a manhole, we usually retrieve the pig through a manhole. However, we can retrieve pigs through another lift station. So you can go from lift station to lift station if you really had to. You just need to ensure that you catch that pig before it goes up into the grinders of the next lift station. Any more questions? That was a great question. All right, I think we're good. Okay. So we've kind of talked through the conventional pigging or foam pigging. I'd like to touch on the smart pigging just a little bit. For those of you who may not be familiar with smart pigging, that's just a very broad term that we use in the industry to say condition assessment technology or condition assessment pigs or smart pigging. So the pig that you see in front of you is a smart pig that is very similar or is the same as a cleaning swab pig, except it's wrapped in sensors. And so different smart pigs are going to be wrapped or covered or even inside of the pig, there's a cavity where different sensors will be placed based off of the need or whatever it is that you are trying to identify or learn about your pipeline. And so I like to just add this in there, because if you are going to set up your pipeline to do foam pigging, that also opens up a lot of other options when it comes time to do condition assessment. And for us, when we do a smart pig run, we have to clean the pipeline prior to, just because a lot of times if the line is not completely clean or clean enough, the sensors and the information that you get back may not be reliable. It very well could be that whatever leaks that you could be looking to detect may be covered up by some of that debris. And so that's why you're always going to get a better read on your pipe by cleaning it prior to running any sort of condition assessment. On the page here, we kind of just go into some of the technology that you can find that's common on these smart pigs. So electromagnetics, acoustics, calipers, IMU, and you can even put a camera on these pigs. And so really based off of what you were trying to get, you can get pretty much everything that you'd want. You can even put ultrasonic technology on these pigs, which will allow you to get both internal and external defects. So for instance, if you're down in the Southeast where the soil is highly corrosive, a lot of times people down there are more concerned about the external defects than they are for the internal defects. And so ultrasonic technology is great for that because it'll allow you to see the outside of the pipe as well as the inside. And these pigs, as I said before, they behave and they operate very, very similar in a similar manner to the cleaning pigs. And so 90s are not a problem. Size of the pipe is not a problem. For a lot of these, especially for the one that we use quite frequently here, the speed is not an issue. This thing can go about, I think, 25 feet per second through the pipe and still get very, very good data. And it's going to be able to compress by about 40%. So these tools have come a long way, and they are incredibly versatile and incredibly capable, and they are also a lot more cost effective and price-wise, they've also come a long way since even about 5 years ago. Let's see, we've got a question here. All right. Permanent solution can be installed into an existing and new force main. Yes, you can install a permanent solution in terms of a pig launching station, but in reality, you don't need to have necessarily a launching station with, say, a launcher. So for us, when we go and go to a force main or go to a client, we just need that blind flange connection at the lift station. Or if that's not present, or if, say, the bypass line isn't close to nominal size, then yes, we would say that you need to tap into the line to drop in the proper fitting. Again, the valve and the Y piece, and then usually you can leave just the Y there. And that would, with a blind flange, and that would just allow whoever the pigging contractor is to come and access the pipe that way. And that's really the fastest and easiest way of doing it if you are beyond the new force main or design stage. Brian writes, can you talk about some of the considerations for cleaning a tuberculated drinking water main? Yeah, so. And we'll go into ice pigging right after the smart pigging, and I'm going to talk about water blasting as well. But the tuberculation is always tricky because tuberculation is not always created equal. I'll give an example. So there's been times where we have a client, again, usually in the Northeast, that will reach out to us and say, hey, we've got this old cast iron line. It's heavily tuberculated. Can you pig it? And sometimes we can, sometimes we can't. And what we like to do is we say, cut out a sample or stick of the pipe, and before it dries, have someone glove up and reach in there and try to remove some of that debris, that tuberculation in the pipe. Now, if the tuberculation is a little bit softer and some of it starts to break off, then we say that you can pig that line. Now, you may be restricted in how far the pig will go, and you may have to break up the segments of the runs, but you can still pig it. If you can't pig it, then you're going to have to either replace it or water blast it. And water blasting is a technology that I'll talk to at the very end of this. But again, as I said before, for tuberculation, we're going to start off with that lighter density foam swab and then move to the wire brush pigs at the very end. And those wire brush pigs will remove that tuberculation, and it will get that pipeline back down to near bare metal. So it is highly effective, and it is possible to remove that tuberculation from those drinking lines, those water mains. Great question. Any other questions before I dive back into the presentation? All right. So just to talk about what a deliverable could look like for the pipe for some of the smart pigging. So this is just a great example of what you can expect to see. These smart pigs will pick up, 5 millimeters, sometimes even better, of any sort of anomaly in the pipe. It's going to show you exactly where it is on your pipe. So lat long coordinates, and then even within the clock position where it is on your pipe. We've actually done projects before where we were brought in to clean the line and run a smart pig with the client, thinking that this line is 40 or 60 years old and there's no way it's going to be salvageable. But let's just make sure before we spend 10, 20, $50 million to replace it. And sure enough, this job that we did in Kansas, it showed the owner of the pipe that they had a couple of decades left of pipe life expectancy, and that there were no anomalies or corrosion that was greater than, I think, 15% in maybe 2 or 3 spots. And the contractors and the engineers who we worked with, they did a verification dig and saw that, yes, in fact, those spots had a little bit of corrosion, but overall that pipe was still in great shape, and they were able to continue to keep it in play. This is the last smart pigging thing I'll show, and then we'll move into ice pigging. And this is just a flyover video of a force main that we did. So we cleaned it, and then we ran a smart pig through. And then as the smart pig went through, it recorded the different areas where there was corrosion, as well as the anomalies that were found. And so you can see that there was no wall loss greater than 20% anywhere in the pipe. And there was only 2 places where wall loss was 10 to 20%. And now this is I'll pause here real quickly, but this is a heat map where you can see where the greatest corrosion and anomalies were found. And so this also helps you all as pipeline owners or consultants to prioritize any sort of rehab or replacement efforts that you might need to do. So, instead of trying to rip up and replace the entire pipe or rehab the entire pipe, this gives you the exact location of where you should start, or at least to prioritize. Let's play through. Right. So getting into ice pigging. So in 2021, our company purchased the rights and the equipment to ice pigging from a company called Suez. We purchased 1 rig and are actually in talks to purchase a second rig, which would allow us to then increase our load size, which I'll get into. But the basic takeaway for ice pigging is that it is exactly what you see in front of you, which is an ice slush. It looks a lot like almost a margarita or a slushy that you'd find at a gas station. What we need to inject this slush is only a 2-inch insertion point. And so think about that. In terms of potable water systems, you can launch the ice pig or the slurry. You can launch that through fire hydrants. You can retrieve it through fire hydrants. For force mains, you can launch the ice slurry through air relief valves. And so the restrictions that you would have for foam pigging in terms of the prep work or mechanical and fitting work that you might need to be able to make a pipeline foam piggable, you don't need to do that for ice pigging. You just need that 2-inch insertion point. For a lot of people who are a little nervous to do any sort of foam picking, it's not uncommon, which is one of the reasons why we purchased and started doing ice picking. For ice picking, the ice, if it ever gets hung up anywhere, it's just going to melt. And because it's food grade table salt, there's nothing to worry about in the system. There's no need for disinfection or anything afterward. And then for those of you who are in areas where water is difficult to come by or very expensive, ice picking is going to use about 50% less water than flushing, and it's also going to be significantly more effective than the flushing. And I'll also show you all a video at the end here about ice picking versus flushing. As I said before, with the pigs and foam pigging not being able to go through butterfly valves, ice picking has no issues going around butterfly valves. Also changes in diameter. Ice picking has no issues navigating multiple changes in diameter. So really, it is a highly effective way of cleaning a pipeline that otherwise would not be foam pickable. Quick history, just ice picking's been in the States here now for over 10 years. Well over 500 projects have been done in 47 different states. We say 2 inches to 42 inches diameter. However, we really, with the setup that we have right now, and I'll show you in subsequent slides what the rig looks like. But because we have one rig, we really don't like to go over about 24 inches. And for a pipeline that is 24 inches, we can do about 500 feet. Now we are likely doing a job that's about 30 inches, but that's just because we have to do it, and it's going to be maybe 200 to 300 feet of effective cleanliness. But then as you start to get smaller and smaller in diameter, then that ice pig is going to travel further and further through that pipeline. I think we posted something to LinkedIn about a week ago that showed, I think it was a 12-inch line where the ice slurry or ice pig was able to make it about 1.5 miles through that 12-inch line, which was really impressive. So this is just a good visual, this kind of glacial river that just shows you kind of how the ice will travel through the pipe. So we always like to say that the ice is going to behave like a liquid, but it's going to act like a solid as it moves through that pipe. So it's going to scour the inside of the pipe, and it's going to remove all that debris, whatever is inside the pipe. It's going to remove it and have it travel along with the rest of the ice pig as it goes to whatever the ultimate terminus point is. It could be a manhole for force mains, or it could be a fire hydrant for potable water systems. Okay, so controlling the semi-solid. So this is a great picture right here of the 2 rigs that make ice pigging what it is. And so our ice pigging team, we like to call them our band of gypsies because they travel all over the country. But our ice pigging team will drive these 2 tractor trailers to a job site. And then the rig on the right-hand side that you can see, that is the ice making rig. Those are the ice generators. On the left-hand side, that is the ice delivery vehicle. And so you can see there is quite a footprint for the actual service and for what is required. All they need is a potable water system to hook up to in order to generate that ice. It makes a 2,700 gallon batch of ice, which is about 10 tons. It's made with food grade table salt. And then based on what the debris is that we're cleaning, we're able to actually adjust the freezing point. And so, for instance, we've actually gone on some cast iron lines where they had a little bit of tuberculation in there. Luckily, it wasn't super hard tuberculation, but we made the ice at a lower freezing point, which then allowed it, or then it had it at a higher scour. And so we were incredibly effective at removing a lot of that tuberculation debris. Now, if you have, say, a PVC line or a line that may be a little bit more delicate, that you don't want to have a really heavy scour to it, we will lighten that up, and it will provide a much more delicate clean, but still a clean nonetheless. Does going back to the questions here, does potable water pigging waste require special discharge considerations? So discharge considerations are always state dependent, and that's something that we often just work with the client based off of whatever their own environmental requirements are. A lot of times we're able just to discharge for potable water systems. We just discharge the debris right into a storm drain. Sometimes it's a little bit more restrictive, and we need to have a vac truck hooked up to remove that debris. And so we can easily catch the debris and have it go directly from the pipe, for instance, for potable water systems into, say, a frac tank or to a lagoon, and then have a vac truck come and suck up that debris, just making sure that, you know, we're moving at a rate where we're not going to have any sort of overflow or any other debris or problems. And then for the same thing for any other system, force mains, what have you, you know, you can discharge really to wherever the client or state regulations permits. Another question coming through is, how do salts affect treatment facilities downstream? So the salt is less than, I think it's about 2%, maybe less, potable water, or sorry, salt. So there is no effect to treatment facilities downstream. There's been numerous times where we'll actually launch on force mains and retrieve, or they'll just have it go right to the treatment facility downstream, and there's never been an issue. There's been countless clients who've, you know, they've done the work and just made sure that the brine solution wasn't going to have any problem. But just because it's such a low amount of salt that's in there, it is just, you know, there's so much else that's mixing with it that it gets heavily adulterated, and there's no effect whatsoever. Good questions. Okay, so as everything has limitations, right? We talked about some of the limitations for foam pigging, limitations for ice pigging. So tuberculation seems to be a common theme for everybody and one of this presentation as well. Again, we go to the rule of thumb, or the hand rule, which is if you can remove the debris with your hand, ice pigging will remove it. If you cannot remove the debris with your hand, there's a good chance that foam pigging will remove it, you know, using the higher density and those wire brushes that we talked about. Now, if we see a picture and we see how hard that tuberculation is, again, we're going to suggest something like the water blasting, which we'll get into on the very last slide here. And so again, large diameter pipes, we don't like to go over 24 inches right now. We are in the process or in talks to get a second rig. And if we got a second rig, that would allow us to make a 20-ton batch of ice, which would then allow us to go up to about 44 to 48 inches of effective cleaning for larger diameter pipelines. So especially out on the West Coast, where a lot of those transmission lines are much bigger and they have butterfly valves in the system, you can't pig them. So ice pigging is a great opportunity or a great option for cleaning those larger diameter lines with those butterfly valves. Okay, so I'm sure for all of you out there who are utility providers, you're going to use flushing. Everybody does UDF flushing. It's the most cost effective, and you know it is effective to a degree. However, it is going to use a great deal of water, and naturally, you know, water is just not going to provide the same level or the same scouring as ice pigging or foam pigging. So we like to say that ice pigging is 1,000 times more shear. Again, it's going to use significantly less water. So all those places where water is very valuable, ice pigging is a great solution. Again, it's for ice pigging, the pressure in the pipeline is never going to exceed static pressure. So if you have a pipeline where you think that maybe the integrity or there might be an issue with going above the normal operating pressure, ice pigging will never exceed that operational pressure. And so it's a great opportunity and a great option to clean a line that may be, may have some iffiness to the integrity. So for potable water systems, this is, we always say a picture is worth 1,000 words. And so when we do ice pigging, we like to use our bottle test. And this is great for the client as well as our technicians. And so on the left-hand side is water as completely untouched before the ice pigging gets involved. And then as the ice slurry starts to travel through the pipe and into the, usually it's another fire hydrant downstream, as the ice travels through, you start to see the sediment and the debris coming out. And then you can see that it starts to get darker and darker until at the very end, you're left with clean water again. And so this shows not only to the client, hey, look, this is how much debris we were able to remove from your line, just in these bottles plus everything else that came out that wasn't captured. But it also shows to our techs, hey, this line is now clean. If it wasn't, then we would never really see any sort of bottles and clearer water. And that would be an indicator for us that we need to do another run, another ice pigging run to say that this line is actually clean and to remove all the leftover debris. Now, we've done this long enough now to where we can say pretty accurately, especially with sludge lines and force mains or anything else where the debris is really, really tough to remove. We're going to tell you how many passes we are going to more than likely need. And that way, when we, comes to budgeting or giving you a quote, we're going to say, hey, look, we think this is going to need 3 passes. And if it doesn't, then obviously you're going to save some money. But if it does, then it's not something like you need to worry about a change order or you didn't have the proper budgeting to make sure that that line was cleared the way you need it to be cleared. All right, so going into, again, UDF is one of the things that we're always going to harp on with UDF versus ice pigging. So back in 2021, we were brought in to do a side-by-side comparison of UDF versus ice pigging. And so Confluence Engineering brought us in Idaho, and they had the local utility company run their UDF program like they would. And then right after they were done, we ice pigged that very same line. And as you can see, that is all of the debris that was removed, or those are the samples that were taken from that line that had just been UDF'd or unidirectionally flushed. And so you can see just how much has been removed and also how much was left in the pipe prior to ice pigging coming in and taking it all out. So great visual just on how a typical setup would be for potable water system. We're going to launch usually through a hydrant, and then we're going to retrieve through a hydrant. We have on one of our auxiliary vehicles, we've got a flow analysis system, so that can show turbidity and a number of other things, water temp. So we can see and show the client, just how effective everything was post ice pigging. We also provide an option to send the samples, the water samples, off to the lab, so that way you can see exactly, how much debris was removed and the before and after of the water quality. I'll go over this slide and see if we have any questions. So this is a typical just hookup for a force main. So usually we're going to go through air relief valves. Again, that we just need that 2-inch insertion point. We're going to launch the ice pig through that air relief valve. The system's going to be off when we're doing that, and then you're going to turn your lift station back on, and those lift station pumps are going to push that ice pig through the force main, and then usually out at a terminus manhole or at a treatment facility. All right, I'm going to move over and see if we have any questions. Is it possible to get a copy of today's presentation? Absolutely. we'll, at the very end, if you do want a copy, we'll certainly provide that. If you want to provide your email, and just let us know. Another great question is, what are the pigging options for glass line ductile iron pipe? It's the same options. You may not be able to obviously use as abrasive of pigs, but you can certainly pig those lines with ice pigging, or even with swab pigging. Next question is,
they're close.
vacs.
I just talked to them. They said they're maybe like 10 or
Sorry,
15
someone's
minutes out. They
muted or
found some other
unmuted.
issue that they had to adjust when they were on there. So shortly.
All right. Sorry, guys. So do air vacs interfere with either foam or ice pigging, and what is done to clear those during the cleaning process? I'm trying to understand. So is air, no, so there's no interference with any sort of, there's air or gas pockets or anything that could be in a pipe. Ice pigging as well as foam pigging is going to remove any sort of air pockets that are in the pipe. And so especially, if you're looking for gas pockets and force mains, if you pig the line prior to doing a condition assessment, you're not necessarily going to be able to identify where those gas pockets are. However, what we like to do is show the areas where, the elevation is obviously a bit higher, plus the level of corrosion would be there as well. And so that's how we identify areas where there might be gas pockets in, say, force mains after pigging has been done. But pigging will remove any sort of gas pockets that are in the pipeline. Again, I always like to go back to a case study. We've actually done some webinars with the Naperville utility company. But again, ice pigging is just as effective as foam pigging. And it increased flows by about 20% and decreased runtime of their pumps on their lift stations by about 20%. And so again, ice pigging was able to pay for itself roughly in about 9 months. And we see, there's been actually a number of times, especially with foam pigging, where we've actually seen flows on force mains that exceeded their initial flows that they got when the force main was first put into service and they first started actually recording their flows. So again, pigging is incredibly effective as both foam pigging as well as ice pigging. Okay, so we're coming up on the end here. The last technology that I want to go through with everybody is just the rotary head technology. And so for the rotary head, it's basically, it is a long hose with a head on it, as it says, rotary head, and it provides an 8,000 psi blast of water. We also call it a water blaster. This thing is also referred to as the nuclear option. So as I said before, if you can't do foam pigging or if you can't do ice pigging, you go to foam pigging. If you can't go do foam pigging, then you go to water blasting. And water blasting will remove anything that is in that pipe. It is so effective at removing the debris that if you do not have enough of wall thickness still left, that water blaster will start to create pinhole leaks in your pipe, which is why, again, we always like to have a stick of pipe cut out, or at least shown to us prior to recommending any sort of technology, because we don't want to make an already bad situation worse. So if the line is very thin in terms of the wall thickness, we're going to say, you need to either replace this, or you're going to water blast it, or sorry, you can't water blast it because it's so thin, you're going to have to replace it. And so we're not going to try and make the situation any worse, and we're going to be completely transparent. Another great thing about the water blaster, though, is that you can go through hydrants. It will clean up to about 500 feet at a time, and it can navigate T's and elbows without any issues. And so again, this is it is a great solution to removing that heavy tuberculation that are so often found in these old cast iron lines. But don't always make the assumption that your cast iron is beyond, beyond saving. A lot of the cast iron that was made before World War II is outstanding cast iron still, and there's still a great deal of thickness left in that, to where you're just going to be wasting money if you just decide to rip up and replace the whole thing. So certainly look at all of the options to include water blasting